really goes back to the staff that we have there at the facility, and we really understand the challenges of operating in an R&D environment, and how do you scale this technology up to a point where it's been hardened enough that it's ready for prime time.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about a path for developing successful next-generation technology, in this case for fossil fuels. Many of you have heard me talk about my time running a carbon capture association in Texas about 10 years ago. My guest today operates a facility that tests many of these technologies while providing a collaborative environment for taking these ideas to the next level. 2 episodes ago, we spoke to Steve Winberg, the head of the Fossil Group at Department of Energy, and we'll explore several of those topics today. You'll remember he said this about carbon capture technologies.
When I got to this job, one of the first things that I asked us to get moving on was reducing the cost of carbon capture. If you look at the CCUS value chain from capture through to injection underground, about 75% of the cost is in capturing that CO2 molecule.
These costs have always been a challenge for removing CO2 out of a power plant's exhaust or flue gas. Secretary Winberg says he'd like capture to be cut in half. My guest says they have reduced these costs about a third over the last 10 years. He and his team operate a facility where anyone with a technology, which he calls developers in the interview, can bring their technology and have it tested in a real-world scenario. They have access to an operational coal plant, which can provide a slipstream of flue gas to these developers. From there, they can test any number of technologies that can pull the CO2 out. I was curious if this was too limited. After all, coal plants burn all kinds of grades of coal, and they produce different CO2 concentrations, nitrogen oxide, sulfur dioxide, and particulates. What my guest explains is that the gas provided to these developers has already been scrubbed, and no matter where a plant is or what it's burning, clean flue gas anywhere in the U.S. is pretty consistent, actually. You also hear me talk a lot on this podcast about the need for natural gas carbon capture. This facility says they are soon about to ramp up a natural gas-fired boiler system to test those conditions as well. Despite all this infrastructure, the key to the test center is its support staff. My guest and I spend a good section of the interview talking about the benefits they provide, from physically setting up equipment to designing the tests. I was also surprised to learn that even if new intellectual property is developed on the site with help from the staff, the IP still belongs to the developer. It's no surprise that these collaborations can last long after the tests are completed and the equipment is sent home. Several of these technologies have gone on to demos, as they're called, or commercial tests. It reminds me of Billy Madison, the film where Adam Sandler has to repeat every school grade for his family, and yet as he progresses, he was always happiest with the third graders.
Gee, I can't wait till I go to high school.
Don't you say that. Stay here as long as you can. Cherish it. Gotta cherish it.
Shaking the kid's face. Thanks to facilities like these, technologies that can solve the carbon issue for fossil fuels can graduate to bigger opportunities. It's operations like these that help lay the groundwork. My guest today is John Northington, director of the National Carbon Capture Center in Wilsonville, Alabama. The center is primarily funded by the Department of Energy and operated daily by Southern Company, the utility that serves the area. You may remember me discussing this center with my panelist of utility guests, including Southern, at the NAYGN conference in episode 65. This center has a huge staff, about 150, that started up in 2009, about the same time I was working at the Clean Coal Foundation, Texas. Since then, the center has hosted about 60 different technologies and had its share of foreign guests as well. Many of these guests coordinate with the Department of Energy project managers, like my NETL guests in episodes 79 and 81. I hope you enjoy my conversation with John Northington. We're here with John Northington, director of the National Carbon Capture Center. And John, tell us about some of the technologies that have been tested at this facility.
Yeah, well, since the center was established in 2009, we primarily focused on carbon capture technologies for fossil fuel-based power plants. In our post-combustion test facilities, we've tested a variety of different technologies in this space, from membrane systems to sorbents, advanced solvent-based capture, enzyme-enhanced systems, systems and some hybrids of those as well. All of those processes are designed to remove the CO2 from a power plant's flue gas stream. And so these processes we test could really be applicable over a wide range of industrial applications, even outside of the power sector. And from those who may know, post-combustion capture is really referring to that after the fossil fuel has been burned, capturing of the CO2. So in the roughly 10 years of operation at the facility, we've completed about 110,000 hours of technology testing. That's representing about 60 different technologies through that period. And from that work, we've already been able to reduce the cost of carbon capture from fossil fire generation by more than a third. And we expect to continue to see future cost reductions as the program continues.
Tell us a little bit about what is there at the facility. Is it just a coal plant and then there's ports where they can get some of the flue gas? How's it set up out there?
Yeah, so we're co-located on the site of an existing coal-fired generating station, and we bring a slipstream of flue gas into our test facility, and then we can distribute that through a variety of different test bays at varying scales. We also provide to all of our developers all the utility connections that they would need. So really kind of a full system operation approach to doing R&D in this space. And so the developers have pretty much everything at their disposal when they arrive at the site. They also have, and probably the most important part, is our staff. Very highly specialized, has done operation in this space for a number of years, and so really understands the challenges of R&D at this scale and how to continue to improve the technology, make recommendations, support the development of the technology to push it out further up the technology scale to commercial demonstration.
And so they're getting the flue gas, and I know there's a lot of different carbon capture technologies that want to try to capture the different grades of coal. Those of us who are familiar with this know that lignite coal is different from subbituminous coal and all those different grades. Is there any way, if someone wanted to say, hey, is there a way to maybe simulate lignite versus something that's higher grade? Does that make sense?
Yeah, that makes sense. We typically get the coal flue gas that the plant is providing, and so this plant was designed for a bituminous coal. We've had a couple of different variations of coal, so we've had the opportunity to utilize those differences during testing here at the facility. But we do have some ability to tailor that stream as we're accommodating different test needs. We've looked at the impacts of some of the trace components in the flue gas and how that affects some of these carbon capture processes. So we do have the ability to tailor to some extent, but from a standpoint of the flue gas from the coal plant, rather, we get what they send us.
Can you get flue gas that hasn't been scrubbed?
So where our slipstream comes off, we come off downstream of the scrubber. But like I said, we do have the ability to tailor that to some extent. And also, we'll be expanding our facility to provide not just coal-fired flue gas, but also natural gas-fired flue gas in the future with an expansion of our mission there at the center.
Yeah. As I'm asking that, I'm going, well, if you think about it, all coal plants, no matter what grade coal and all the bag filters and scrubbers and everything will have done their magic on the flue gas by the time it would be hitting any kind of post-combustion carbon capture system out there, right? I would assume that's how you're able to say, well, look, it doesn't matter what the feedstock is. It's all going to be scrubbed to this spec.
Yeah, that's right. If you look at the majority of coal-fired generating units, most of them have the same level of environmental control on the back end of the plant. So the stream that they're getting at our facility from a coal-fired flue gas standpoint would be fairly representative of the broader fleet across the country.
John, who pays for the tests? Is there a fee to use the site? Is that rolled into, say, people get grants from DOE? How is that worked out?
Like so many research projects, and I know you're familiar with this, the funding is highly leveraged to try to deliver the most value. So our facility operates as a cost-shared R&D collaborative. 80% of the funding to operate the site comes from the Department of Energy through a cooperative agreement, and the remaining 20% is provided by Southern Company and our other cost-share private sponsors. That group of private sponsors that we currently have at the facility is a fairly diverse group. We have oil and gas industry represented. We have a lot of representation, obviously, from the utility and coal industries. And so a fairly diverse group there, but we take that funding that's provided to support the test installation, construction, operation and maintenance, engineering and data analysis. Everything that goes into supporting the developer's test is paid for by those funds. The developer would be expected to fund their their module or test skid. So the design and construction of that, transport to the site, any employees that they might be required to have on site to support testing. And then also looking at it from a standpoint, if their tests required any specific infrastructure addition that we didn't currently have, oftentimes the developer has provided that as well. But to a large extent, when they come to the site, outside of paying for their own project deliverables that they have, their testing there at the facility is covered by the funding that I mentioned previously.
What about international companies? Could a German company or a Japanese company come in and use this facility, or is it only stateside ventures?
Yeah, so we're very active from a standpoint of international technology developers coming to test at the facility. At this point in time, we've already worked with about 30 different government, university, and research organizations spanning across 7 different countries. And we expect that to continue to grow through time. I mean, we're constantly fielding interest both nationally but also internationally in coming to the facility. And then we've also co-founded an international test center network. It's a global coalition of facilities similar to the National Carbon Capture Center, they really have a joint goal of promoting a level of readiness for CCUS. But the goal there is really around sharing lessons learned and results at each one of our facilities that could be parallel activities, increasing insight and awareness of the technology and enhanced public acceptance and awareness as well. And then also working with the technology developers, a lot of times each one of our facilities provides a little bit different scale, a little bit different infrastructure. And so oftentimes it's advantageous for our technology developers to then be able to connect with some of these other facilities in our network to be able to test and operate under different conditions, kind of further hardening the technology, if you will.
It's a good networking opportunity. You've joined a brotherhood, right?
Absolutely.
Yeah. How long do participants typically run their tests at the facility? What's considered enough data?
It kind of depends a little. For instance, a developer, based on their own project schedule and deliverables, there may require more or less time at the facility. Another one that we often run into is scope and scale. Yeah. So are we doing a component test, which might be able to be executed faster, or a fully integrated system at a larger scale, which may end up testing over a longer period. But a typical test run usually spans about 1,000 hours. That may not be necessarily consecutive, but we usually allow about 3 calendar months to be able to obtain that test data. But within the confines of that test, we usually begin with a lot of parametric testing, varying the operating conditions in a controlled way to define what the operating envelope and performance is for the system. And then from that work, settling on an optimum condition to operate at for a steady state or longer term duration test. And in those parts of the test, we may look at things like degradation of the process over time. The goal is to really provide enough testing time for the developer to be able to confidently then scale up from the test that they've done at our facility.
Right. I've tested equipment before in the field, especially when I was out in the oil field sector, and we'd go there for a weekend and be, we're good. And it's not always that simple.
No, it's not, for sure.
John, you said you had staffers there. I bet they play a very important role for a lot of these companies that come in. And look, I'm sure most of them, this is the first time they're coming there, I'd have to imagine that they offer advice. They've probably had a lot of experience with other projects that have gone through and have ideas about how to streamline some of their tests. How hands-on would you say that they are?
Yeah, extremely hands-on. And that's, to me, of everything that we have at our facility, that's the most important part. That's the thing that we often hear the feedback from our developers on the most is the staff and what we're able to provide. I mentioned in the beginning that Southern Company operates and manages the site. We have a fairly long-term and industry-leading R&D organization. We just passed 50 years last year, and that team has a tremendous amount of technical depth to be able to bring to bear, and we really understand the challenges of operating in an R&D environment and having an eye towards how do you scale this technology up? How do you get it to a point where it's been hardened enough that it's ready for prime time and commercial operation? We really have somebody that's in that space with the developer every step of the way through the process, from the beginning of onboarding their technology to our site, all the way through design and construction, operation, troubleshooting and data analysis, and then demobilization on the back end. And then we usually continue to maintain touch with them as they transition past our facility and on to other test test opportunities. And in addition to that, the fact that we do have the infrastructure that we have there at the site, we're able to test at multiple scales so we can simultaneously test multiple technologies all at one time. And so that kind of serves to further accelerate that development timeline. And our team's very adept at doing that.
Yeah, this whole idea of working with these staffers, I got a bunch of questions for this. Look, I would think that one of the things that could help out were things like, hey, you don't need to test more for this. Streamline this test here. This is what people really want to see.
Absolutely. Absolutely. No, we work with them quite a bit, not only on aspects of design that we've run into before with just assembling components, but also, like you're pointing out, from a standpoint of developing the test plan. We have conversations with our DOE project management, so we're very attuned to that and kind of what some of the goals and opportunities are. And it is oftentimes well received, sometimes saves not only time, but tremendous amount of dollars by not having to go through some of those more painful lessons that we've learned through time in the development of a lot of technology.
And I can also imagine the scale. Is the throughput of the test unit large enough to prove scalability, especially if you're going to go 2 orders of magnitude larger on a commercial unit? Is that big enough to prove concept?
Right. Yeah, we have the capability to test as large as what we refer to as a 1 megawatt equivalency of flue gas. So it's what would probably be qualified by DOE as a small pilot. It gives them enough confidence to then be able to scale to a large pilot test or demo, which is still not quite necessarily a commercial unit, but that kind of gives you an idea of where we fall. And on the front end of that, we also can go down small enough to take things straight out of the laboratory and expose it to real world conditions. So lots of flexibility there at the site. But when we see the developers move, and we've seen several now who have moved past this point and have scaled up to other tests, about 7 or 8 of those in total. And some are even looking at feed studies right now on the operation of a commercial facility in the future. Tremendous amount of benefit.
Yeah, and 150 staffers. This collaborative effort here, I would have to imagine that new intellectual property comes out of it and new IP is written, and I assume that happens quite a bit.
Yes, actually it does. I mean, it's one of those things that we identified fairly early on in these relationships that we have with the technology developers. Obviously, they're going to bring their own IP to the table. And so the way we've kind of arranged our agreements, we refer to them as technology collaboration agreements, we're able to properly protect certain pieces of information. And then obviously, with it being a DOE-funded facility, a public facility, the expectation of certain information that's reported on out of the test there at the facility. And so you have those 2 buckets, and then in between is the one that we use to handle information that we need to know to help successfully and safely execute the test. But the way these agreements are written, any IP that's generated there at the site is the property of the technology developer. It's done on purpose in order to create the environment that you really need to move these technologies forward.
Yeah. And you say the Capture Center has been in operation over the last 10 years. I would say this has probably been the quickest 10 years in the history of the energy sector. I mean, think of all the things that we've seen over the last 10 years, fracking and so much with renewables. And of course, this. Have you seen any trends shift over the years, say to more utilization technologies? We hear a lot more about carbon capture and utilization.
Yeah, in fact, we've expanded our current mission with the Department of Energy to include carbon utilization and then also direct air capture. So if you're thinking about the full portfolio of carbon capture technologies, we're expanding to include support of testing and development of those technologies at the site as well. As you mentioned, I mean, there's increasing interest, I think, in the carbon utilization space beyond enhanced oil recovery type applications. And so looking at things like captured CO2 and using it to make building materials or fuels or plastics, lots of different potential alternatives there could serve a lot of different opportunities. One might be helping offset carbon capture costs for power generation or providing an alternative to a traditional manufacturing process. And perhaps as an alternative to where maybe some generators may not have the ready access to EOR or storage opportunities as a pathway for utilizing the CO2. So lots of different opportunities there. We actually have 3 utilization technologies right now that are scheduled to test coming up here in the near future. And then also on the direct air capture side, we're working with DOE right now to support of that technology into testing there at the site. Right now, we're pursuing a lot of research agreements with national labs, universities and other research institutions that are focused in this area to help provide some clarity on really what the needs and challenges of the technology are as we branch off into adding this to our testing schedule there at the site, and looking for opportunities ultimately to provide a host site in the case of the direct air capture work, and making sure that we have that there. Our research, obviously, just like with carbon capture, is going to focus on reducing costs, improving performance, enhancing the integration of the system, and ultimately doing all of that with an eye towards moving to a significant scale.
Yeah, you mentioned the direct air capture. I'm just wrapping up a podcast with Steve Winberg at Department of Energy, the head of Fossil. He was so entertaining.
He is great to talk to.
He mentioned direct air capture, and I wish I had parked on that for a second. This may be a little bit political, but direct air capture really is a way to make the tent a little bit larger for carbon capture, especially with the environmental community. I think a lot of environmentalists are like, why do we want to try to help coal out? But direct air capture is one of these things that's super green in a lot of people's imagination. So I would understand why wouldn't you try to also include that in the program, right? I think it has a lot of goodwill to it, and I think it will be effective.
Yeah, and that's right. And in the world that we're in now, and I'm thinking of it from a Southern Company perspective, if you have a goal to achieve a net zero future, these negative emissions technologies like DAC will have a part to play. Based on where it is today, cost and performance are probably not where you want those to be.
Yeah, and so DAC would be pulling CO2 out of the air. Why would you want to do a direct air capture project at the National Carbon Capture Center? We could go off on a hilltop. What's the advantage? I guess the staff, right?
Right. That's exactly where I was headed. It really goes back to the staff that we have there at the facility to help support the development of the technology from where it is currently. With all of these direct air capture systems, they have an aspect of CO2 capture. Yes, they are doing it on a very dilute stream of CO2, but the challenges are very similar from a standpoint of how you drive cost and performance relative to carbon capture. Our staff has a lot of experience there. In addition to just direct air capture from the air, there has been talk of looking at how you might integrate these technologies with point source capture.
Yeah.
We've supported several DAC technology developers in some recent FOA responses, providing some letters of support and volunteering the center as a host site for potential research and development needs they may have in the future.
Right. Again, it sounds like the human resource is probably the most important part of that facility, right? I mean,
absolutely.
Yeah.
It's what makes everything else possible.
Sure. Okay, so we've discussed carbon capture, utilization, and storage. You and I have talked about DAC. What sectors would you like to see at the center that could use some development?
It's going to be imperative to further develop carbon capture technologies for integration with the nation's natural gas combined cycle units. That's going to be, I think, an important area of focus in the near future. And as I mentioned, we were expanding our facility to include the capability to provide natural gas, flue gas, to our developers as a part of that testing. Not that we won't continue to test on coal, because we'll still have that there at the facility, but also our R&D team at Southern Company is constantly looking at how can we integrate other projects with the National Carbon Capture Center in conjunction with our DOE project managers. It's feasible that we could host other demonstrations there at the facility on our footprint in the future. And one small example of that is we have a cybersecurity project that we're testing out right now that's DOE funded to look at monitoring system for a control network. Well, our control network is not tied to a power generation station, and so there's a lot less risk there. And so it was an opportunity that we saw, and we're doing that testing as well in addition to the carbon capture work. I see the facility as a very useful tool for DOE going forward to use in a lot of different cases. I will never say never when it comes to what types of technology we might test in the future.
You might just do a black start test on the plant, right?
That's right.
Yeah. When your guests leave, there's usually byproducts, maybe captured CO2 or CO2 as fuel. For instance, maybe they turned it into ethanol or something. Do you have arrangements in place where people can maybe take that CO2 off so that they're not taking their own equipment and the byproduct that was produced?
Yeah, the CO2, I'll start with that. The purpose of our test site was never really to sell the CO2, so there's no infrastructure to enable that. Realizing that as we run these tests, the developer will capture CO2, and the way the site is configured, all of that goes back to the plant to go back through the environmental system. There is no open loop there, if you will. The new natural gas system, we actually will have a separate permitted stream and stack that we will use, and those those two systems will be separated from an environmental standpoint. But you're right. With some of the tests, there are certain byproducts that might be generated. Oftentimes, we identify those on the front end with the developer and decide how that will be handled. Some of that might be taken by the developer for additional testing. We've seen that happen. We could also maybe hold that material there at the site. Oftentimes, a lot of these developers have multiple tests and projects that are going on in parallel. In certain cases, we've reused material for testing there at the site. And then the final is when all the testing is done and we've decided that there's no further use for the material. We take ownership from a standpoint of handling it. The developer will usually pay for the cost of doing so.
Man, you guys are full service.
Start to finish.
Start to finish. That's right. All right, John, one of the things I admire the most about Southern Company is that they really do embrace it all. And I mean, you look at what's going on at Vogtle, the nuclear plant that you're building. You're the only company in the country that's doing one right now. You've done carbon capture technologies before. Tell us what it means to work for a company that tries to be on the leading edge of these generation technologies, where I think there's a lot of groups that would rather be the second or third out there to maybe be the ones to put this out in the field.
Yeah, I guess the first reaction there is it's an exciting place to be and to work at. We really view ourselves for our company as the tip of the spear. And if we're going to get to the future that we all want to, it's going to take technology and it's going to take a lot of learn by doing, which has kind of been our philosophy at Southern for a long time. The company recognizes that net zero future, and it's not just one technology, it's going to be that portfolio of technologies. You mentioned the advanced nuclear. In addition to building the first new nuclear units in the U.S. in about 3 decades at Vogtle, we're also working on advanced reactor technology and molten chloride fast reactor with DOE and TerraPower. TerraPower is a Bill Gates founded company. We have a very fast growing program focused on hydrogen economy and potential uses of hydrogen, looking at renewables and storage. We have researchers right now that are working on tall wind testing, lots of work on in-use and microgrids, and then also lots of work on EVs, looking at electric vehicles. So I get to sit on the front row and participate in a lot of this research. There couldn't be a better time to be an R&D at Southern Company, and specifically at the National Carbon Capture Center.
I'm sure it's a blast. I'm so jealous.
Well, feel free to come take a visit anytime. We'll be glad to host you.
You bet. Thank you so much. All right, John Northington, National Carbon Capture Center, thank you so much for your time.
We really appreciate it. Thank you for the opportunity, and have a great afternoon.
That was John Northington, director of the National Carbon Capture Center in Alabama. John shared with me some of the non-DOE partners they have, which include many utilities, oil companies, and associations like ClearPath, which is also here in Charlotte like me and was a guest on episode 3, Small World. And you heard John say they were looking into possible technologies involving direct air capture. As I was cutting this episode last night, I got an email from the Southern States Energy Board that they've received funding from DOE to test DAC, where else? At the National Carbon Capture Center. Congrats to everyone over there. I've known Ken Nemeth and folks at SSEB for years. I want to thank John for his time, as well as Joe Al Striggers and Frank Morton at Southern Company for setting this up. You can find plenty of pictures on energy-cast.com, as well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sending the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 92. Be sure to join us next week when we explore the potential of the next generation of fuels powering our nuclear fleet. Until then, I'm Jay Downhauer. We'll see you next time.